Welcome to this class on Neuroscience of Human Movement. In today's class, we will be talking about a particular dysfunction of the basal ganglia called as Parkinson's disease. So, this is the intro class on Parkinson's disease. The other videos on Parkinson's disease will focus on specific models of Parkinson's disease and possible therapeutic approaches. So, in this class, we will review the role of dopamine in Parkinson's disease. We have discussed the importance of dopamine in earlier classes many times, and we will describe a particular case or a particular form of Parkinson's disease called as idiopathic Parkinson's disease. So, which constitutes the great majority of Parkinson's disease is, the great majority of Parkinson's disease is idiopathic. So, the other form that is known to be genetic or specific genes that cause PD have been identified in a smaller proportion of the cases. So, about 10% of diagnosed Parkinson's disease is actually genetic. The remaining, the large majority continues to be idiopathic, right. And then a particular form of Parkinson's disease that is acquired due to consumption of a specific drug or a specific chemical called as MPTP, and how the discovery that MPTP consumption leads to irreversible damage to neurons in the substantia nigra pars compacta actually resulted in a particular experimental approach in basically in using animals for development of convincing anatomical and phenotypically convincing models. So, Parkinson's disease was first described by James Parkinson. Of course, that is the name, that is the reason the disease has his name, because it was first very elaborately described by James Parkinson in his essay on the shaking palsy. So, he called it as a shaking palsy. Later it was found that this is a disease of the dopaminergic nigrostriatal pathway. So, this is a disease that is caused due to degeneration or selective degeneration of neurons in the nigrostriatal pathway, or those neurons that are responsible for producing dopamine, right. And let us remember what the role of dopamine is, right. The role of dopamine is to cause a net excitation at the thalamocortical level, right. So, what are the symptoms of this disease, right? Classic symptoms, classical symptoms of Parkinson's disease, right. Stooped posture, right. So, like that, like you see this person here, right, like that, stooped posture. Inability to take the first step, this is called as freezing of gait, and if the person is walking, you see what is called as shuffled gait, right, like that. So, actually the videos that you could see on YouTube are much better. I am not able to actually reproduce that, right, shuffled gait. And in general, difficulty in initiating movements, akinesia, as in the absence of voluntary movements, bradykinesia, slowness, rigidity. This is of two types: cogwheel rigidity, lead pipe rigidity. The pathophysiology in these two cases are different. Importantly, these people have an inability to express emotions by facial expressions. So, their faces are like a mask all the time, no reaction. For any particular news, anything you tell them, there will be no reaction in their face. So, no emotional expression by changing the facial muscles. So, why? Because in general movements are compromised. Facial emotional expression is essentially movements, right. Expressing an emotion through the face essentially involves movements of the small muscles that are involved. right. So, in general when movements are compromised, then these movements are also compromised, leading to a situation when the person looks like a mask, right, mask like face. And then pill rolling movement of the hand like that, I am not able to exactly reproduce. There is a movement that is caused by the index finger and the thumb like that, right, and that movement is happening like that, and that is accompanied by a tremor of the wrist like that. Both of these simultaneously happen, right. So, this is called as pill rolling, right. And in general, reduction in blinking, micrographia or handwriting size becomes smaller, and then resting tremors. So, essentially pill rolling then develops into a different form called tremors, resting tremors, right. So, these are the classic symptoms. Among this, anybody can recognize these some of the more classic symptoms: tremors, shuffling gait, stooped posture, classic symptoms of Parkinson's disease, right. What causes? Well, what is known is that it is a neurodegenerative condition of the substantia nigra pars compacta of the basal ganglia. Then there is a hypothesis, there is an idea that repeated punctate injuries of the brain, such as those that occur in contact sports such as boxing. So, here we have the picture of the greatest of Muhammad Ali, right. He suffered from Parkinson's disease for nearly 4 decades before he passed away recently. Let us take a moment and appreciate his philosophy to movements, right. Float like a butterfly, sting like a bee. What it means is that, well, it could have any number of meaning. It is not clear for me exactly with what meaning he mentioned that. This was of course before a fight when he taunted one of his opponents. Of course, he was known to be very talkative, especially expressive before the fights, and he used to taunt his enemies. There are many ways in which he played his game. This was one of his psychological games. Of course, you should definitely try to watch his fights, the famous fights such as the Thrilla in Manila. There was a fight that took the boxers close to death, right. There are others that you should this, right, or the so called rumble in the jungle, right, and so on and so forth. There are several. Float like a butterfly, sting like a bee. It is not clear with what meaning Muhammad Ali said that. In my view, this means the importance he is emphasizing, to me, is emphasizing the importance of grace in a boxer's movement. Essentially, when somebody is hitting you, it is very important for you to float like a butterfly, for you to gracefully escape from the opponent's punch. At the same time, when you hit the other person, right, we are talking about boxing, when you hit the other person, it has to be power packed like that of a bee, sting like a bee, right. So, essentially why is this being discussed in this course? Because this is a course on movement science, right. The importance of movements in everyday life, in sports and other activities, artistic activities, right. Here you have to float like a butterfly means what? You have to gracefully move your foot in such a way that you escape the opponent. Such was the statement, at least in my view, that is my interpretation of what Muhammad Ali might have meant. But at least one thing is clear, he was a true master of his art, right. Is it possible that it was his art that ultimately consumed him? His fight was mostly with Parkinson's disease. The longest battle, his longest battle was with Parkinson's disease, not with Foreman, not with Sonny Liston, right. Those are not his opponents. The major opponent for him, the major disabling effect for him, of course, was Parkinson's disease, which he suffered for a very long time, right. Is it possible that Parkinson's disease in Muhammad Ali was caused due to the number of hits that he took, due to the trauma that he took? That is an interesting hypothesis, yet it is not clear what could have caused it. It is entirely possible that this could have been genetic, this could have been due to other environmental factors. There is no evidence to suggest that this is purely due to traumatic brain injury type of this, but at least it is important to keep in mind that this could be one of the contributing factors, right. Of course, other environmental toxins and drugs are known to cause Parkinson's disease. In the case of drugs, for example, MPTP adulterated drugs frequently cause Parkinson's disease. Toxins such as pesticides, these are usually mitochondrial toxins that selectively knock out the neurons in the substantia nigra pars compacta, leading to a situation typical of Parkinson's disease. And then hereditary factors, of course genetic factors, and encephalitis occurring early on in life for whatever reason. So, essentially multiple reasons, we actually do not know why Parkinson's disease is caused, maybe due to some dysfunction of mitochondria due to the exposure to toxins. This is the dominant hypothesis. Of course, there might be some genetic factors which have not been completely understood. So, some genes have been identified, but those only constitute a very small proportion of the total number of disease cases. So, in idiopathic PD, the reason for the degeneration of the dopaminergic neurons of the substantia nigra pars compacta is not known, it is uncertain, we do not know, we are still studying this. It turns out that about 50 to 70% of the dopaminergic neurons in the striatum is lost by the time of death. Actually, what happens is, in many cases about 70 to 80% of the dopaminergic projections of the connections are lost by the time the patient presents with the symptoms, not the cell death, okay. This is the projections, right. So, essentially symptoms appear very late, right. So, by the time the symptoms appear, it is too late, usually it is too late, right. How do you know that this is Parkinson's disease? Well, usually dopamine replacement therapy such as drugs such as L-DOPA or dopamine agonist receptors, sorry, or dopamine receptor agonists, right, are known to improve the condition. So, because of this reason, so how do you know that dopamine is depleted in the system? You cannot actually open up and see, right? There is not an easy way of doing this. One simple way of doing this is to give L-DOPA to the person and see if he improves, right. If the person improves, then that is Parkinson's disease, because in the absence of L-DOPA the person is not able to improve. By giving the medicine he is improving. By the way, let us remember, here we are treating the symptom, not the disease, right. In other words, this is not going to save the neuronal cell death. So, in other words, this is not going to save the neurons that are dying, right. Those neurons that are dying will continue to die. This is only treating the symptoms. Actually, this also does not work on the long term basis, it works for some time, right. What are the environmental factors? Well, rural living, well water are all believed to be some of the causes. Exposure to environmental toxins such as pesticides, so farming, pesticide exposure, exposure to other potent mitochondrial toxins. Let us remember that essentially PD is due to death of neurons in the substantia nigra pars compacta. Why do these neurons die? Because of mitochondrial dysfunction, right, or in other words, if there is a toxin that affects mitochondrial function in the substantia nigra pars compacta, then these neurons will die essentially. So, surprisingly, smoking and caffeine reduce or lower the risk of PD, not increase, right. Smoking and caffeine essentially reduce the risk of PD. Of course, there are other reasons why we should not be smoking. There are so many other risks that come with smoking, but PD is not one among them. A question is, how is this true? So, if you take a group of, how is this even done? I am taking a group of people in the general population and I am taking a group of people in the among smokers, right, and I compare the two. The incidence of finding Parkinson's disease patients among the general population is higher than among smokers. So, nicotine apparently has some sort of neuroprotective effect, that is the hypothesis at least, right. How? What is the neuroprotective component of nicotine? We do not know. So, a lot of these things are not understood, and genetic factors that cause Parkinson's disease. Note, this kind of Parkinson's disease is actually much lower in proportion, right. Mutation of chromosome 4 that encodes for alpha synuclein, right, and defects in the Parkin gene on chromosome 6 and the so called LRRK gene, right. The entire mechanism of how this works, right, how the alpha synuclein encoding is affected, what are the details, right. The moment you want to go into the details, it is very unclear as to exactly how this happens. There are several speculations on of these, right. Oxidative damage, dysfunction in removal of toxic metabolites, and calcium handling is abnormal in these cells. These are all speculations of what happens. It is not clear actually what happens. Many of these are just we think that this is happening. Many of these are actually untested hypotheses. And then the interesting case of frozen addicts, right. It turns out that a group of individuals in San Francisco long time ago, in the, I think in the 80s, consumed drugs or recreational drugs that were adulterated with a particular chemical called MPTP, right. What is MPTP? MPTP is 1-methyl-4-phenyl 1,2,3,6 tetrahydropyridine, right. So, shortly MPTP, that is actually 1-methyl-4-phenyl 1,2,3,6 tetrahydropyridine, right. So, this chemical is mixed, is usually used as an adulterant in more expensive recreational drugs. So, when that is mixed and people consume that, it turns out that people will develop symptoms typical of Parkinson's disease, the classic symptoms of Parkinson's disease, right. Let us remember the individuals who consumed this were young. Usually Parkinson's disease sets, or the onset of Parkinson's disease is at around age 50, give or take a few years, right. So, these young individuals in their 20s, if they got Parkinson's disease or they display symptoms similar to Parkinson's disease, that means they must have consumed something that selectively damaged the neurons in the substantia nigra pars compacta. What is more important is that Dr. Langston actually gave them medication that was used in Parkinson's disease and they improved. So, that means these people have had irreversible damage of the substantia nigra pars compacta, typical of Parkinson's disease, right. So, this is a very potent mitochondrial toxin, that has the ability to selectively knock out neurons in the substantia nigra pars compacta that produce dopamine, right. So, essentially that selective degeneration of this. So, this gave rise to the idea that we could treat animals with MPTP and then develop models of Parkinson's disease using animals. So, these primates, right, these animals formed the major part of animal models of Parkinson's disease. And let us remember that the following are the advantages of this, right. This is a phenotypically and anatomically convincing animal model of the disease, right. Nothing can be better than that, right. Essentially what you are doing is you are inducing the disease like it happens in the real world. So, essentially you are knocking out the specific neurons, so very convincing anatomical model, right, anatomically convincing, phenotypically convincing model, right. What are the problems? let us remember that degeneration of neurons in real Parkinson's disease is a long term process, right. It happens over several years, whereas in MPTP treated animals it happens in a shorter time. So, essentially these two are not the same. So, this is a fundamental problem. In general, this also forms the concerns related to using animal models for studying humans, right. This led to the discovery of the rate model of Parkinson's disease, right. This is something that we will discuss in future classes, right. Dr. Carlson, who won the Nobel Prize in 2000 for his discovery of dopamine and the identification of its role in movement and relation to Parkinson's disease, and hence development of drugs for Parkinson's disease. So, in summary, we have introduced Parkinson's disease, we have discussed the various causes. Essentially much of Parkinson's disease is caused due to no particular cause, we do not know the cause, idiopathic Parkinson's disease. Some of it is genetic, some of it is due to recreational drug use, and the role of dopamine in Parkinson's disease. And we also discussed the specific case of MPTP treated animals as anatomically and phenotypically convincing model of pathophysiology in Parkinson's disease, right. So, with this we come to the end of this lecture. Thank you very much for your attention.